before we even start, I just wanted to thank you all for letting me be a part of this conversation today. Through my 7 years of working in Western Kansas and Eastern Colorado on a PhD and postdoc with lesser prairie chickens, it's become, increasingly apparent how important these NRCS and USDA programs are for wildlife. And I'm really happy to be a part of this conversation and meeting today. So as Tim discussed, we're going to be talking about reducing the threat of land use conversion. And we're thinking most of this at the basic level, how to protect these intact rangelands, these grasslands, these big sagebrush ecosystems. So right off the bat, when you bring in cultivation to the mix, and we're looking at the Great Plains here, you can see that over the last 150 years, a substantial portion of the Great Plains have been converted to corn and wheat, as well as cotton. And there's some portions where subdivision is also a major risk, but I'm going to mostly be focusing on cultivation. And what we're looking at in the bottom right here, this is just a screenshot from Google Earth of Finney County, Kansas. And you can see in there all of the center pivot irrigation that's gone in. You can also see some dryland agriculture. And this has created, a fragment where we have these isolated patches of grassland. And that's not a good thing if you're a grassland-dependent wildlife. But using the same mental model that Jeremy showed earlier and also Dirac, I really like this figure, and it really pertains well to looking at the risk of land use conversion. And if we were to think of it from just a purely grassland standpoint, we could think about these areas in blue as intact cores, which, although there has been a lot of land that's been lost to cultivation, there are some really great areas that we've, still have as intact grasslands. And, some of these areas in yellow would be locations where maybe, there's still some grassland on the landscape, but it's not readily dominating that landscape. And then the areas in red, I think more about areas where we might have just a very high and intense amount of row crop agriculture in that area. So based on, how much grassland's on the landscape is going to dictate, whether you're using preventative measures, like what Dave will talk about later, using conservation easements to reduce subdivision risk, or whether you're implementing, you're focusing more on the grazing practices and things, or if we really need to go into these areas and restore grassland. So to really use this tool, we need to know what's out there, and we need to think spatially. So if we look at this map shown here on the right, this is actually the percent grassland within a 4-kilometer radius surrounding each of these points. And when you're looking at it at this broad of a scale, it kind of just shows what's grassland versus what's not. But if you were to zoom in on it, it would basically show, if you were standing on a hilltop, if you were to make a big circle and spin around, it would show how much grassland is within about 2.5 miles of that area. And this kind of broader scale thinking, or at least this landscape scale thinking, is really important for grass and wildlife, especially in my neck of the woods in Kansas. There's several species that can do all right if there's a, some cropland mixed in with these grassland areas, but those landscapes overall, need to be predominantly grassland. And if we're going to take this mental model and we apply it to this area throughout the Great Plains, if we're looking at Kansas, we're going to need to think a little bit more about some of these reactive approaches to increase grassland, maybe in some of these transition areas. Whereas if we're thinking about northeastern Wyoming, we might be thinking more about getting conservation easements on the ground to reduce subdivision. So turning back to Kansas, if we need to go back and we need to reclaim areas as grassland, one tool that has proven to be particularly valuable is the Conservation Reserve Program. And it began in 1985. It converts cropland to perennial grassland, particularly within the Great Plains. I think this is probably all old news to you, but I want to remind you that this is on 10 to 15 year long contracts. And we're about 35 years out now from when this program was first implemented. So just remember that for just a second. So CRP was implemented. We've been monitoring grassland birds since then. And there's just been this increasing volume of evidence showing benefits to grassland-dependent wildlife. And this paper came out of David Pavlaki's lab, and it shows that the Farm Bill program conserves 4.5 million birds in the southern Great Plains. And it met the desired recovery goals for 4 of the most vulnerable species. This is just huge. If you look at areas outside of these landscapes with which we have Farm Bill programs, there's several species that are declining, and we even have evidence of certain species that have actually shifted their range and are actually doing better than they are in other historic regions due to these Farm Bill programs. So there's a lot of power in these programs. I just can't highlight that enough. But we could potentially use it to leverage even more support for wildlife and also for ranching communities. We could do so by thinking spatially and thinking over broader periods of time. Like I said earlier, these contracts are on 10 to 15-year periods, so they're relatively short duration periods of time. I think when CRP was first implemented, most people probably didn't think that would last beyond that initial 10 to 15 years. But now it's 2020 and it's 35 years later. We need to start thinking about, enrolling CRP, what happens when it expires, what happens when we re-enroll. And from my perspective, what we're looking at today, what questions, I'm really interested in are what happens after those contracts expire, how many CRP fields remain as grassland after those CRP contracts expire, and where are fields more durable after expiration. And I'm going to talk a lot about durability. And this is just this idea that a program or a conservation tool, how durable is that establishment of grassland, once that contract period expires. This could also be thought of as like a legacy effect, or the legacy of CRP beyond those contract periods. So to answer this question and to pursue this idea of CRP durability, we first acquired data from fields that expired in 2007. So about 10,000 CRP fields throughout the southern and central Great Plains shown here. And then we followed those from 10 years out, from 2008 to 2018. And we used remotely sensed data to look at each of those fields throughout this period and decide whether it remained in grassland or whether it was converted to cropland, and also, when it converted to cropland. So we used this information and we took it back and we used kind of a traditional wildlife approach where we looked at using these survival models to model durability over time. If you're familiar with some of the old school population ecology models, you'll have seen this type of survival curve before, typically, for white-tailed deer or grouse of some sort. But what this is showing is effectively that 60% of expired CRP grasslands remained as grassland 10 years after expiration. So I'm going to walk you through this just a little bit. Hopefully it won't bore you too much. But, we started out in 2007 with 100% of these fields still in grassland. Then you get out to about 5 years out in the middle of this graph, and you see that that curve has gone down, where about 40% of those CRP fields that expired in 2007 were converted to cropland. Now, kind of from year 5 to year 10, which is effectively 2013 to 2018, basically what was still in grassland remained in grassland throughout that period. Now you're going to look at this and you're going to say, well, how does this apply to me? That was over a very broad area. Aren't there going to be state variation and spatial variation based on commodity prices and various other factors? And you're actually absolutely correct there. And shown here on the right is when we break up those durability curves by state. And you can actually see in green, we have Colorado mapped over time. And at the end of that period, durability was about 40%, suggesting that about 40% of those fields remain in grassland after this 10-year period. In contrast, in Oklahoma, right over this 10-year period, 80% of those expired CRP fields remain in grassland. But we want to look at it more spatially. We want to see how we can really maximize that durability by how we locate those CRP grasslands. And to do that, we looked at several different variables. Three of them that were most important are shown on the screen here, and that includes tillage risk index, annual average temperature, and proportion of grassland within 4 kilometers. And this tillage risk layer on the left is basically showing exactly what it says. Areas in yellow have a low risk of being tilled or cultivated. Areas in red have a high risk of being cultivated. And we thought that that would inherently be important for influencing the durability of CRP. We thought that annual average temperature might be important. There are certain climatic areas where certain crops are more favorable. We found that temperature was important. And finally, we thought that proportion of grassland surrounding each CRP might be important for a variety of reasons, but maybe one reason might be areas that are more grassland, there's going to be more of a ranching community surrounding that CRP field. So people might be more likely to graze it, leave it in grassland, whereas if that CRP fell in an area that was more cropland, there'd be more tools there and more of a culture established to convert it back to cropland. I'm going to go back to tillage risk here because this is a layer that's currently available on the rangeland analysis platform that Brady showed earlier. And what we found just by using this is we in essence validated this data set. So what we found was that in fact areas that were lowage risk of being tilled, those fields were more likely to remain in grassland. Areas in red here that were more likely to be tilled also had CRP fields that were less durable. And there was actually about a 4 times of a different of a rate. So if we're just using this alone, we can increase the durability of those CRP fields about 4 times. And this layer, this tillage risk layer, takes into a lot of variables. It's actually based on kind of a machine learning approach that takes into account several soil variables, topography, and also groundwater availability. So you can see this area in western Kansas, where the Oglala is, and there's a lot of water available for irrigation in some of those portions. So then we took all of those spatial variables, we combined them together, and we created this overall predicted surface of CRP conversion risk. So I'm kind of changing the terminology here a little bit. Earlier I was talking about durability. To turn it into spatial predictions, we had to show risk of those CRP fields being converted back to cropland. With that being said, you could still look at this map. You can see these areas in dark maroon. Those are going to be areas that are going to have a higher risk of being converted to cropland over that 10-year period. And areas in dark blue are areas where CRP is going to be less likely to be converted to cropland and therefore more durable. So things you can see from this map are the northern extent, we did have some higher risk of conversion to cropland. And also something that was interesting is, further in western Kansas, we saw that areas were at greater risk in some of the areas in eastern Kansas, where there might actually be more precipitation in eastern Kansas, but the soils and the groundwater availability in the Oglala make western Kansas somewhat more of a risk of being converted. But if I were to use this as a state or district conservationist, what I would be looking at is more this scale. So you can zoom in on this layer, and if we zoom in on these 6 counties in northwestern Kansas, you can see that there's a lot of variability within county, and also among these counties. If we look at Scott County, you see this area that's in bright orange. There's a high risk that if you put a CRP in that area, it's going to be converted back to cropland pretty much immediately after expiration. Whereas if you go further east into Ness County, you can see that there are a lot of these areas where, in the blue, where if you enroll a field into the CRP program, it's likely to remain as grassland 10 years following even expiration. And one thing that I skipped over a little bit earlier is that you'll notice that I'm not showing this continuous area throughout our study area outlined in purple, but rather kind of these patches within, and those are actually cropland areas within the central and southern Great Plains, and we've also removed urban areas from this layer. So this is where you could go in and you could directly enroll these croplands into CRP, and they would likely remain as grassland if you targeted it correctly. One thing that I wanted to dig into a little bit more in the 6-county area is that if we were to look in areas that were greater than 60% grassland, if we thought of those as our strongholds or grassland strongholds, and if we thought about areas that are less than 30% grassland in red as being areas based on that mental model that we showed earlier, these would be areas that we'd need to bring in an ambulance, maybe a ladder truck. There'd be a lot of work, a lot of reactive effort to build up grassland dominant landscapes at a scale that would be relevant for wildlife. But these areas in between the black and red, are areas where I think it would be really good and useful to really target CRP enrollment to kind of expand out among these areas that are already 60% grassland. Maybe we could connect them. I think there's a lot of potential that could be done with this. And with that being said, we've gone over the broad scale factors looking at targeting where to enroll CRP, but one thing I want to highlight is that we need to think about what's going on within these CRP fields after expiration as well. If they're regularly hayed, intensively grazed at a high rate, instead of being well managed, there's going to be very different outcomes for wildlife. And this field on the bottom, this actually was an expired CRP. It was signed up in the Lesser Prairie Chicken Conservation Initiative, and we actually found multiple nests out on that field. Now, zooming back out, we can use CRP to target and fill in these gaps. And based on these durability maps, we can potentially fill them in for much longer periods of time than just the contract period. So if we begin to envision enrollment and expiration of CRP fields over longer periods of time, we can really buy more time and effectively even buy a more spatial extent. And in that essence, the impact of CRP would become greater than the sum of acres currently enrolled. And I want to finish just with this figure right here, just to show this to you again. Using CRP to piece together grassland dominated landscapes in areas of low conversion risk would be, I think, very beneficial, especially when we're really thinking about it spatially and targeting it around intact cores. We could also use this to target conservation easements as well. This is something that I'd like to discuss with you guys further and kind of brainstorm about in the future. But Dave Naugle and Kyle Tackett are going to give some examples of where conservation easements have been used to really leverage a lot of benefit for wildlife in Montana, and I'm really excited to pass it along to them so they can tell their story.
So a mindset underpinning a proactive strategy to reduce cultivation risk includes two big factors: keep grass green side up and fill in the grassland gaps. Possible tools in the box include easements, or, as we just heard from Dan Sullins, an ability to transition from idled lands to working grasslands, and then to plant back cultivated lands to perennial grasslands. It's important, again, in this mental model to conserve core intact grasslands by addressing cultivation before conversion establishes too big of a foothold. Part of that is to resist the urge to invest first in landscapes that are too far gone. Next slide. I'm going to take you on a quick 15-minute tour of 3 states that have used easements to effectively reduce the widespread threat of cultivation in eastern Montana, and then a more localized but intense risk of subdivision in Idaho's Pioneer Mountains, and an equally impressive partnership in southwest Wyoming that deserves an entire morning to unpack. But given time constraints, I'll provide you with a link to a video to learn how Wyoming is conserving grazing lands in the Daniel Core area, the densest concentration of sage grouse anywhere in the world. Next slide. In eastern Montana, the primary cultivation risk is dryland wheat farming, shown here in this fence line contrast in the upper left. The landscape is a transition zone between sagebrush rangelands and more productive grasslands in the western Dakotas. Thus, it overlaps existing SGI boundaries and the new geography of the Great Plains Grassland Initiative, shown in this hatched area. In our part of the country, this is referred to as Sage Grouse Management Zone 1. Shown on the right are sage grouse leks and existing cultivation. Sage grouse need sagebrush during every life phase. Therefore, as shown here, they mix with cultivation about as well as oil and water. Next slide. Using the cultivation risk layer that's now available on the Rangeland Analysis platform, we found that cultivation 4 miles from an individual lek reduces sage grouse occupancy. This means that it takes multiple intact townships in size, to support a flourishing population. Quantified here on the right, sage grouse response to fragmentation looks like a hockey stick, with as little as 10% cultivation setting a population on a downward trajectory. Joe Smith, who provided this decision support to practitioners, said it best. A single square mile of new cropland negatively impacts sage grouse in a landscape 12 times that size. Next slide. Next, I'll cover 3 steps that you might find helpful in thinking through your own strategy development. First is identifying wildlife strongholds. We use sage grouse core areas, shown here as blue polygons, wherein 75% of birds are located within just 25% of the landscape, a truly clumped population. Wildlife strongholds are pictured here on top of the cultivation risk layer, so you can follow our train of thought to the next step. If you don't have wildlife strongholds readily available in your backyard, I'm thinking your Game and Fish and other partners can help. Next slide. Second, we prioritized intact landscape cores by cultivation risk. Red, orange, and yellow are higher risk compared to the grays and blues shown here. This insight provided practitioners one more piece of information as they moved into decision making. Next slide. The third step of the Venn diagram is to assess cultural will. Here's where this pointy-headed academic is going to step aside and call on Kyle Tackett, pictured here, who's done this entire life. Kyle will forget more about delivery than I'll ever know. Kyle resides in southwest Montana in the town of Dillon and serves as NRCS's partnership liaison for Montana and forever has been our Sage Grouse Initiative state lead. Take it over, Kyle.
All right, thank you, Dave. Can you hear me all right?
We can hear you fine.
Yes.
All right, thank you. Well, this is a tough spot to be in between you and lunch. Maybe second only between you and happy hour, but let's get started. You can go ahead and switch slides, Dan. So I just wanted to offer a few thoughts on how Montana has I would say succeeded in easements over the last few years. And the highlights there, numbers at a glance, were provided by one of our big partners here in Montana with the Montana Association of Land Trusts. To put a little context behind this, our sage grouse habitat in Montana is roughly 2/3 private land. We have some conifer woodland expansion that we work in around the edges, not a huge deal. Annual grass invasion is becoming a bigger deal to us. We're working on it locally, but we're not in that Great Basin type situation yet. We hope to keep it there. So by and large, if we can keep our ranches working, our ranches intact, we've done a lot. So since the 2014 Farm Bill through Ale, we've protected over 190,000 acres through ASEP Ale with our partners here in Montana. And that's not just sage grouse habitat, that's statewide. Just to give you an idea, that's 31% of the 2014 Farm Bill Ale acres nationwide. I want to go through what I view to be four of the high points that helped us get there. Number one, we started with outreach and education. It sounds basic, but it's important. 10 of our 14 core areas in Montana for sage grouse are found in Management Zone 1. We held 6 workshops in the high priority areas. And I would say that these workshops were led by our partners. We invited the applicable land trusts and those landscapes to help. And I would say they're every bit as important for our own employees to participate in. If you're familiar with ALE, it's largely driven by the land trust partners. And so this provided an opportunity for our employees and our partner friends out there to get to know each other, to understand the program better and start building a better relationship. And then also what comes from that is that landowner will, cultural will to move forward with easements. And keep in mind, we may not hear from some of these ranchers for years. They may sit on it, think about it, and when the time is right, they come to see it. We started there with outreach and education. Second, we have invested heavily in Montana in capacity through 2 partners. One is our Montana Association of Land Trusts. We have a partner position that sits in the state office with our easement staff and has been vital in helping kind of shepherd applications through the process, keeping the relationship strong with our partners. And that has been a fantastic partnership between NRCS, MALT, and NIFWIP. And second, for capacity, we've partnered with Ducks Unlimited for 2 positions in Montana. Once again, one in the state office that sits on the easement staff there. And while their focus at times may be more on the wetland side, that position has been absolutely vital as we look to deliver and get these easements over the line, whether it's wetland-based or ALE. And we also have an area office position in our prairie pothole region with Ducks Unlimited that overlaps nicely with their sage grouse core area up there. So getting some on the ground help through partner capacity, really focus on some of those wetter areas in that prairie pothole region. So second, investing in capacity. Third is investing in relationships. We have a very well-developed, very engaged land trust community in this state, and that's sage grouse habitat, non-sage grouse habitat all over the state. We value the relationship we have with them, and we invest heavily in improving on it and maintaining it. A lot of it comes down to having a 2-way street for communication here. We have some very honest and transparent conversations. Anybody that's worked in the easement world knows it's not always roses. It's not easy. When you're trying to close easements, there's oftentimes, emotions come into play with landowners, family dynamics, timelines change. And so having that relationship with the land trust that you're working with, and it could be, in our case, FWP, our Fish and Wildlife Agency we work with on easements, where we can have those maybe tough conversations and have those honest conversations. It's been vitally important to success in life, especially when times get tough. And last, we have to deliver. And this is not always easy. We've been pushed here in this state to deliver as the easements keep coming in, the applications come in. In FY19, there were 18 ALE applications that came in from our partners here in the state, totaling $25 million in requests. And so we have to deliver, and that's where the relationships and the capacity come into play. And ultimately, I think success breeds success. And so we've been able to continue the success and look forward to continuing our relationships with our land trusts. And we have land trusts that don't work in the sage-grouse world, that are busy working in the more urban interface, keeping open space open, and that stuff is just vitally important as well. And to kind of piggyback on the last conversation, on top of easements, we also offer a seeding initiative through SGI, where we're really targeting those already tilled fields and trying to get them back to that perennial grassland state. And then we are working through our targeted EQIP approach on expired CRP. So on top of the easements, really looking at a couple other options. So next slide. I wanted to highlight just one quick area here in Montana. This map was provided by our friends at the Nature Conservancy and Brian Martin. At the top of the map there, you'll see a black outline for a core area up there. And then in the middle of that is a Bitter Creek Wilderness study area. And Naugle and other folks can do this more justice than I, but from a biological perspective, this region of the state supports the longest known sage-grouse migration, upwards of 100 miles. It's international, involves Canada. And Todd Cross and Jason Tack and others have really looked at how these birds kind of use a stepping stone approach to move through the landscape. And this Bitter Creek Wilderness is one of those spots as they move south towards the CMR refuge further to the south. And so our friends at the Nature Conservancy have just piled in and really targeted that Bitter Creek area, and the green squares, the green blotches there around that Bitter Creek area are permanent conservation easements that our friends have been able to put into place through partnerships in that landscape. We just got this map. I don't have the acres updated there, but just wanted to highlight how easements in Montana have been used to really secure that public-private patchwork that we have, and really secure some of these intact landscapes for the migration. So with that, Dave and Dan, that's all I have, and I can take questions at the end if time allows. Thank you.
Hey, thanks for a look under the tile. I do appreciate your skill sets, man. So let's totally switch gears now. And I'd like to take you to the Pioneer Mountains of South Central Idaho, where the Pioneer Alliance is using easements to reduce land use conversion again, but this time it comes in the form of subdivision threat. This effort is well targeted within one of Idaho's sage-grouse core areas, once again, shown here in purple. Let's zoom in for a quicker look. Next slide. Here, everyone wants to own 40 acres and a horse while they gaze at the beautiful Pioneer Mountains. Moreover, it's only a 25-minute drive from Cary to Haley and another 13 miles up to Sun Valley if you want to hit all of the ski lodges. The white-colored rangelands interspersed on this map between state, Bureau of Land Management, forest, and the Craters of the Moon National Monument, they can all be subdivided on private lands, impacting their rural ranching communities and the wildlife that they support. NRCS easements here have helped fuel this exciting partnership to conserve all of the easement tracts shown here in green. Mixed ownerships also support a world-class pronghorn migration with radio-marked animals depicted by pink dots. Looking at this, you might think at first that the road is an impenetrable barrier. But let's look at pronghorn migration. Next slide. Pronghorn moving from summer range, shown in the lower left here, skirt the foothills. If you look at the background shot on the right, through distinct migration corridors, and then spill out onto winter range and back again, with winter range shown at the top right of this slide. Conservation of big game migration is an added beneficial outcome of this incredible partnership. Next slide. In closing, I would love to show you a very similar strategy that's reducing subdivision risk in Southwest Wyoming. But with time constraints, I'll let rancher and longtime easement holder Maggie Miller do that in our SGI video about targeting easements in Wyoming, with the link here that Brady's also sending you now via the chat box. A second resource you might find useful is a recent interview with Lisa McCauley about the ins and outs of easements and Montana's recent push that Kyle told you about in Montana. This was all part of Working Lands for Wildlife's Ask an Expert series. And lastly, in an article that Working Lands for Wildlife produced on Montana easements, as the third link, highlighting my long-term friend and mentor's work, TNC's Brian Martin. Thanks for your time.